Hello, dear CS50 staff. My name is Reljakovacevic. My EDX username is reljakovacevic, and my GitHub username is Rxlja. The date of this video being recorded is the 17th of August 2025. The year and month of this specific incident is August 2025. The reason why I wanted to pick this topic is because I myself have a certificate for the Salesforce Admin Beginner course, so I found it really interesting how the company I acquired this certification by has managed to get hacked so easily. It has also impacted dozens of other companies which work with Salesforce, for example, Salesloft, which was also really interesting to me. Another reason was that this incident had every bit of every lecture we had involved in it, which made connecting the dots way easier. The given usernames you see on the screen are all lowercase. So, what is on the agenda today? First of all, we're going to talk about the context regarding Salesforce. Then we're going to talk about the incident and what happened. Then we're going to dive a little bit deeper with our technical deep dive. Then we will have the impact and mitigation, and then we will come to our conclusion. Before we get into the specifics of what happened and how it happened, we need to lay down the basics first. Salesforce is the world's largest customer relationship management platform, short for CRM. It is a massive and secure digital Rolodex where companies store everything about their customers, such as names, emails, phone numbers, support tickets, sales history, so very sensitive data for a company. Salesloft is a so-called sales engagement platform used by sales teams to automate emails and calls. They own Drift, which is an AI-powered chatbot, the kind you often see on websites with occasional "How can I help you" pop-ups. So, how does this even connect with each other? Companies connect Drift to Salesforce so that when the chatbot talks to a potential customer, it automatically saves that conversation into the Salesforce database. In August of 2025, a Chinese Nexus espionage group, identified as UNC6395, executed a supply chain attack. Instead of trying to hack into thousands of companies individually, they only hacked into one vendor, which was Salesloft. But how did they do that? The attackers first compromised a Salesloft employee's GitHub account, where they found hard-coded credentials for Salesloft's cloud servers, which are AWS. Once they gained access to these servers, they did not shut anything down. Instead, they located a database containing OAuth tokens, the specifics of which I will get into later, which essentially allowed the Drift tab to talk to its customers' Salesforce accounts. Using these keys, the attackers impersonated the Drift chatbot. From August 8th to August 18th, they silently accessed the Salesforce instance of over 700 companies, which included major cybersecurity firms, all while downloading sensitive customer data. To the victim companies, it only looked like Drift was doing its regular job. Now that we have the fundamentals laid out for us, let's jump into the technical aspects of this attack. OAuth 2.0 is a standard protocol for app-to-app authorization. The concept is as follows. When a company installs Drift, they don't give Drift their Salesforce password. They verify their identity once, and Salesforce issues a token, which is basically the principle of public and private keys. This token has limited permissions when used, but it does not require a password to be initialized. These are not the only tokens that have been used by Salesforce in the companies. We need to differentiate between the access tokens and refresh tokens. Access tokens are a form of short-lived tokens, for example 2 hours, which are used to read data. Refresh tokens, on the other hand, are long-lived, maybe a few months or even years. These are used to request new access tokens, which kind of work like a loop. The adversaries stole the refresh tokens, which allowed them to generate valid access tokens on demand, which also effectively gave them a permanent logged-in session that bypassed MFA or multi-factor authentication. The adversaries used SOQL, or Salesforce Object Query Language, as you can see on the screen on the right-hand side, which is a code that is very similar to SQL, to run automated scripts to query the database for specific high-value text, searching for keywords such as password, AWS key, username, first and last name, or secret that might have been accidentally pasted into the support tickets. Adversaries also wrote a script to loop through the list of tokens which connected to each customer's Salesforce instance and ran queries to download data. Now quickly, I would like to link this to the CIA triad. I'm sure you guys know, but for the sake of fundamentals, I shall still explain it. The CIA triad in cybersecurity refers to 3 core principles: confidentiality, integrity, and availability. These principles guide organizations in protecting sensitive data, ensuring it is only accessible to authorized users, remains accurate and unaltered, and it is available when needed. Looking at the aspect of confidentiality, we can say that it was broken since it was the primary failure. Unauthorized individuals gained access to private and sensitive data, causing hurt to companies that work with Salesforce. Integrity was preserved since the adversaries did not alter, delete, or encrypt the data. Availability also remained preserved since the systems remained online and functional, causing no downtime or service interruptions during the time of the attack. Now, during this attack, the impact was immense. Over 700 organizations had their data exfiltrated. The incident highlighted that even if a company such as Salesforce, which is the world's biggest CRM, can secure itself with firewalls and passwords, it is still vulnerable to backdoor attacks such as third-party apps. The industry was forced to recognize that service account bots and apps need just as much protection as human users. Some companies, such as Okta, which is basically an American identity and access management company, which provides cloud software that helps companies manage and secure user authentication into applications, they mitigated this attack because they restricted the API tokens to specific IP addresses, which we will get into later. Now, Cloudflare, for example, confirmed that 104 of their internal API tokens were exposed through these tickets, meaning that hard-coded passwords, VPN configurations, and server logs were exposed. Salesloft had to take the entire Drift application offline globally in September of 2025 to isolate the code. Hundreds of companies suddenly lost their chatbot and sales automation tools, which caused massive operational disruption. So now, what are some precautions companies should take in order to protect themselves from these kinds of attacks? IP allow listing could be used in the sense that Salesforce allows admins to restrict API access to specific IP addresses. If a company had said that they only accept Drift tokens from Drift's official IP address, the attack would have failed, since the adversaries were using their own computers from their own servers in China or VPS. If IP allow listing was on, Salesforce would see the valid key, but would be able to deny the request, which would ultimately cause the attack to fail almost instantly. Another precaution would be that when installing apps, admin should review the permissions. If an app asks for full access but only needs to read email addresses, the request should be denied. As an example, admin should only grant the scope of cases.read and not data.export or even sys_admin. If the bot only needs to write to the chat logs folder, it should not have read access to the passwords folder. This links to the lecture content of the security principle of least privilege. Another precaution is a principle of token rotation. So just like when we change passwords, companies should regularly rotate OAuth tokens so that if an old one is stolen, it is practically deemed useless. Now, finally to conclude, the Salesloft and Drift incident of August 2025 serves as a wake-up call for the entire cybersecurity industry. We saw how a single compromised GitHub account could cascade into a massive data breach, affecting over 700 organizations, including some of the biggest names in tech. This attack proved that in our modern, interconnected world, you're only as secure as the third-party apps you trust. While companies have spent billions securing with strong passwords and multi-factor authentication for humans, attackers have found their ways through non-human identities and OAuth tokens. So the takeaway from this is clear. We must treat software connections with the same suspicion we treat human logins. By implementing IP restrictions, enforcing the principle of least privilege, and actively managing our digital keys, we can close these doors before attackers can walk through them, so to say. My name is Reljakovacevic, and this was my final project for CS50. Thank you so much for watching.